Welcome to all in this lecture. This is the third lecture in the series of beams. In this lecture, we are going to study the loads on the beams and its type. So let's start. So what are loads? There are various loads acting on the beams. So what does the word load means? It is just the weight of anything. Buildings, rooftops and all other constructions apply their loads on the beams. Loads can be of various types depending upon the nature of the weight application. That is, the load is applied at a single point, or the load is applied uniformly over the beam, or it is non-uniformly applied. On that conditions, there are various types of the loads. So moving forward, this is the first type of the load, that is the concentrated point load. Here all the weight is concentrated at a certain point on the beam. If this is a beam AB and a force F is applied at a point C, then at point A and at point B there will be reaction forces RA and RB perpendicularly upwards to the beam, and the force F will be acted at a point C. Okay, was the first type. Now let's move to the second type, the uniformly distributed load. That is, the weight is uniformly distributed over the beam. Load is distributed uniformly over the beam, see here. And to solve, that is to draw some conclusion out of it, to solve, the uniformly distributed load is assumed to be acting as a point load at the center of span. That is, if a intensity load W is acting over the beam, then the maximum weight will be applied at L by 2, because it is the midpoint of the beam. If L is the span, then L by 2 will be the midpoint of the beam. So the force F, see here, the force F is applied at the length L by 2 from the both the sides. Okay, now coming to the second conclusion, what will be the force F? What will be the magnitude of force F? We know that W is the intensity of loading and the loading is uniform. And L, this is L is the span of the beam. Then W into L will be the total concentrated load, that is F will be W into L. That is, we can also call it as the area of loading. Okay, F will be the area of loading, or W into L. What is W? Intensity, and L is the span of the beam. See here, so the force F is applied at length L by 2 from both the sides, and F is equal to W into L. There are other two representations for the uniformly distributed load at point A and B. If the AB is the beam, then uniformly distributed load can be shown in this wise also, and a single line with downside pointing arrows. This is also the way for showing the uniformly distributed load. Moving forward, there is also a concept known as uniformly varying load. Here the load is decreasing at a constant rate over the beam. That is, in any direction the load is decreasing. See here, if this is the beam AB, here if starting from this point the load is constantly getting decreased at a certain rate, or if we assume that this is the starting point, then the load is getting increased at a certain rate. Okay, the uniformly varying load is converted into a point load. How it will be converted into a point load? So see, first of all, we know that from the last example, that is from here, we know that the load will be W into L. The load will be W into L for uniformly distributed load. So W into L is the area of this rectangle. So if we find the area of this triangle, then it will be the force. It will be the concentrated point force. So we know that for the area of a triangle is equal to half into base into height. So we will write half. So base is the length, total length or the span, and here we will assume that the intensity of load is W and it is the height also. So half into L into W will be the point force that is applied. See here it is given F into half into L, F equal to half into L into W. This is the concentrated point load. Okay, now moving forward, see here, W is the intensity of loading, uniformly varying loading. L is the span of the beam. W into L divided by 2 or W into L into half. This is the total concentrated load. Okay, now the most important question, where will be this point load applied? Where will be the F point load will be applied? We have to answer this question. So see here first, if we think from this point of view, more load is applied in this part, so the force will be near to the point B. So from the point B, or where from the point where the load is more, the distance of the force F will be L by 3. That is 1/3 into the length of span will be the position of force F. And from the lower side, that is, less load is applied at the point A or the region at the point A. So the distance will be 2L by 3 from point A. See here, from point A the distance is 2L by 3 for the force F. This is the point where the force F is applied. Okay, see here, load acts at L by 3 distance from the peak or from the higher end. Okay, and load acts at 2L by 3 distance from the lower.